Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at inverse functions. And this is just a little bit of a recap, all right? Now, one of the things that people have to remember is whenever they're looking at a function, that function is either going to be a function that is not one-to-one, all right? Now notice here, in this function, we can see it satisfies the vertical line test, but it fails the horizontal line test. Now, when it fails the horizontal line test, it identifies itself to not be one-to-one, even though it is a function. Whenever you have a function that is not one-to-one, you're going to be forced to find some point, in this case a vertex point, where we will be able to divide it in half and look at one half or the other. This is restricting the domain of the original function to either work with the right portion or the left portion of the graph. All right. So once again, this is a function, but it is not one-to-one. And when we are forced to graph its inverse, we have to make the choice of whether we are doing the positive portion of the domain or the negative portion of the domain. And you notice that's towards the left. This is restricting the domain. And when we do this, we create different functions. For example, this top function turns out to be a square root function, whereas this bottom is the negative square root. And in calculus, there are going to be questions that you're going to have to check the initial condition, the point that they gave you at the beginning, because that point could be in the positive square root function or the negative square root function. And because we will be restricting our domain, it will be one or the other. And part of the last points of that FRQ or those types of FRQs is to make sure that you include the appropriate sign, be it positive or negative. Now, the functions that are the easiest to work with are the functions that are one-to-one. A straightforward cubic, for example, looks like a tangent but without the asymptotes. And what you'll notice is this is y equals x cubed. It satisfies the vertical line test. It satisfies the horizontal line test and is therefore considered a one-to-one function. And one-to-one functions always have inverses. And the problem is sometimes it's really hard to figure out what that inverse is. In this case, we know that the way we can find the inverse is by exchanging the x and the y values, and then we take the cubed root of both sides, and we end up with our inverse function, the cubed root of x. And that goes up this way and this way. Now you'll notice it has 2 points that intersect both of these curves. This is not for all functions, but some of them, and they sit on the y equals x axis. This is a 45-degree angle, and it is called the inverse axis, in case you're curious. So we now have this idea of a one-to-one function. The inverses have points that are now reflected through this y equals x axis. So that if I have this point on the original graph called xy, its inverse is now y comma x. And they've actually flipped places. All right, so be aware that we can then start to say inverse functions are functions where f of g of x is equal to g of f of x, which will always equal x for the domain of f of x that is the range of g of x, and vice versa. And these are now inverse functions. Then f of x and g of x are inverses. So here's a nutshell what we're talking about when we're working with these things. And I hope that this reminds you of things that we can do. How do we find an inverse? The definition of an inverse? The reflection through the inverse axis? The idea that this works for all functions that are one-to-one? Not all functions are one-to-one, and when they are not one-to-one, we are forced to choose and restrict the domain of the original function in order to find out an inverse function. This is the difference between a conic that's a parabola, which is a relation or a function, versus those that are square root and quadratic. Alrighty, thank you very much. I hope this has helped. If you found this useful, please remember to click like. Thank you very much, and have a wonderful day, Hornets. Cheers. Bye-bye.